Dear students, very good morning. Today we are going to discuss about K-map minimization. Okay, so already we discussed about minimization techniques in digital electronics. In that we discussed about what is minimization techniques, what is the objective of minimization techniques. Now, one of the minimization techniques is K-map minimization, Karnaugh map minimization, also known as K-map minimization. It is an important minimization techniques. So let's discuss why K-map minimization. Okay, so K-map simplification technique is a simpler and less error prone compared to the method of solving logical expression using Boolean laws. Okay, its main purpose is to simplify Boolean algebraic expression. Okay, so, main objective is minimize the Boolean algebraic expression. This is the main objective. Okay. So next, this is the Karnaugh map. Why it is called Karnaugh map means this map is invented by the scientist Karnaugh map, also named as K-map. The K-map was introduced by Dr. Maurice Karnaugh in year 1953. So that's why it is called a K-map. Okay. So next one is K-map rules. K-map is a pictorial method of grouping together expression with common factors and then eliminating unwanted variables. I hope you understand. K-map is a pictorial method of grouping together expression with a common factors and then eliminating unwanted variables. K-map uses the following rules for simplification of expression by grouping together adjacent cell containing ones. Okay, so in this diagram, group may not include any cell containing a 0. If we group that cell containing 0 means it is wrong. Okay, how we have to group the cell contain 1 in here means we can group as a 1. Okay, so this is the right technique. Okay, group may be horizontal or vertical. Students, now we are discussing K-map rules. What is the purpose of K-map rules? To minimize the Boolean expression. Okay, we do not map like this. Okay, we have to group us like this. Okay, group may be horizontal or vertical but not in a diagonal method. In this diagram you can understand the concept of grouping, how we have to group. Next, third is group must contain 1, 2, 4, 8. In a general 2 power n cells, if n equivalent to 1, a group will contain 2 ones since 2 power 1 equivalent to 2. If n equivalent to 2, a group will contain 4 ones. That is 2 power 2 equivalent to 4. Okay. So next K-map rules, each group should be as large as possible. Okay, each group should be as large as possible. So here we have a 1, 2, 3, 4, 5, 6, totally 6 ones are available. We cannot group as a 3 individual groups. We can group as a 2 groups. Okay. Each cell containing a 1 must be in at least one group. Okay, each cell containing a 1 must be in at least one group. Okay, so next one is group may be overlap. Group may be overlap. Okay. Groups may wrap around the table The leftmost cell in a row may be grouped with the rightmost cell, and the top cell in a column may be grouped with the bottom cell. So in this diagram we can understand very clearly. Okay, so we can group like this and like. Okay. Next one is there should be a few group as possible as long as this does not contradict any of the previous rule. Okay, so we have to group like this. Okay, individual as strong as possible we have to group. Okay, so now it's the time for activity, students. For this session, which number replace the question mark in the circle? Which number we have to replace for this question mark? You have to understand the concept here. What is the logic behind this? Okay. Next, in K-map, types of variable. Okay, K-map is most suitable for minimizing Boolean expression. 2 variable, 3 variable, 4 variable and 5 variable K-map are available. So K-map for 2 variable. The number of cell in 2 variable K-map is 4. Since the number of variable is 2, there is only one possibility of grouping 4 adjacent minterms. The possible combination of grouping 2 adjacent minterms. Okay. So next one is K-map for 3 variable. The number of variable in variable K-map is 8 since the number of variable is 3. There is only one possibility of grouping 8 adjacent minterms. Okay, so the possible combination of 4 adjacent minterms are M0, M1, M3, M2. Okay, so like that we have to make. After that, K-map variable for 3 variable x, y, z. We have to place x here and y, z in this direction, x and y. So simply you can understand. See, here we have to x map, here y, z are mapping. So 2 variable means the combination may be 0, 0, 0, 1, 1, 0, 1, 1. So 1, 0 have to come here, M2 place. M0, M1, M2 and M3. We cannot write seriously M1 next to M2. Okay, M1 next to M3 and then finally M2. Okay, so 0, 0, 0, 1, 1, 0, 1, 1. Okay, so next for X it may be 0 or 1. So this is the K-map variable for 3 variable. Okay, so here the number of cells is the 4 variable. Okay, so 4 variable means x, y or w, x, y, z. So 4 variable means 2 power 4 equivalent to 16. So 16 cells are available, M0 to M15. So there is only one possibility of grouping 16 adjacent minterms. Okay. Next is the K-map for 5 variable. The number of cell in a 5 variable K-map is 32. Since 2 power 5 equivalent to 32. There is only one possibility of grouping 32 adjacent minterms. There are two possibilities of grouping 16 adjacent minterm. Grouping of minterms from M0 to M15 and M16 to M31. If B equivalent to 0, then 5 variable K-map becomes 4 variable K-map. Okay. Students, now it's the time for assessment. Who introduced K-map is the Karnaugh map. Okay, a K-map is an abstract form of dash diagram organized as a matrix of squares. Okay, so which diagram you have to find. Next one is that there are dash cells in a variable K-map. Summarize the rules of K-map. Plot a 4 variable K-map. So thank you, students. I hope you understand the concept of K-map and what is the importance of K-map in Boolean algebra minimization. Okay, so thank you, students.